To determine the molar enthalpy of formation of butane, we are still going to use this formula. The enthalpy of the reaction is equal to the difference between the enthalpies of formation of products and reactants. So we have the products, carbon dioxide and water, and also the reactants are butane and oxygen, 2 moles, 13 moles, 8 moles, and 10 moles. And also, importantly, we're going to pay attention to the signs of the enthalpies of formations. So let's write down what we have. The enthalpy of this reaction is equal to, we're going to start from the products. So we have carbon dioxide, and it is 8 moles. So it's equal to 8 times the enthalpy of formation of carbon dioxide plus 10 moles of, we have water, so enthalpy formation of water as a liquid. And then we're going to subtract the sum of the reactants. So what we have is 2 moles of butane together with 13 moles of oxygen. And all of these together is equal to the enthalpy of the reaction as shown here. So we have negative 5,755 kilojoules. That's how much energy is released from this reaction in this exact amount of moles or reactants and products. One thing that we learned in the previous video is that the enthalpy formation of the oxygen is 0 because that's the elemental form of the oxygen. And so we just cancel out here. And at this point, what we want to do is we need to rearrange this equation a little bit and get an expression for the enthalpy formation of butane. So we can move the enthalpy formation to this side of the equation and bring the enthalpy of the reaction to this side. If we do that, what we have is that 2 times enthalpy formation of butane is equal to 8 times we have the enthalpy formation of CO2 10 times the delta H of the water plus 5755, and we divide this by 2. And here we just need to add the numbers. So the delta H of formation of butane is equal to 8 times we have negative 393.5 kilojoules per mole, 10 times minus 285.8 plus 5755, and all of these divided by 2, which is equal to negative 125.5 kilojoules per mole. And so if we keep 3 significant figures based on what we had initially, this is equal to 126 kilojoules per mole negative. So that's how much energy is released when 1 mole of butane is formed from carbon and hydrogen.